Hey folks, Mr. Dell here. We are looking at a problem that has to do with solving equations. In this case, you can look at these as equations with um, fractions, or you can even call them proportions. These are proportional equations. So I'm pulling these questions. This one I'm going to be doing is 1-28, and this is from CPM's Math 1, right? So Math 1, CPM Math 1, and specifically 1.1.1.3, number 1-28. Okay, so the problem is we have m over 6 is equal to 15 over 18. So I'm looking for what is m, right? There's a few ways to do this. I want to figure out what is that number m that makes this proportion true, right? So what I look at is, first of all, I'm going to say, remember, it's m over 6 is equal to 15 over 18. So I look at this 15 over 18 and I think to myself, is there a number that can I simplify this first? Right? I can simplify. It's a fraction, right? I can actually simplify this one. This one I can divide top and bottom by 3. I can simplify it with a giant 1 of 1 over 1, or 3 over 3, by just dividing top and bottom. And what did that become? That becomes now 5 over 6. So now my equation is m over 6 is equal to 5 over 6. So we can see right away, well, m has to equal 5. So that's one way, as long as the actual fraction there, it could be simplified. Another way of doing this, and I'm just going to rewrite this question so that way you see the other direction. If you didn't see that right away, you may have to use a different method. And the other method I would use is a concept called fraction busters. Basically, you find what is the common denominator of each of those fractions and multiply by it, right? So 6 is and 18, the common multiple there is 18. So I'm going to multiply by 18 over 1, because what I do to one side of an equation, I could do to the other, right? I need to do the other. So if I multiply both sides by 18, I keep my equation balanced. And if you notice, 18 over 1 times m over 6, right? The 18 and the 6 simplify. 6 becomes a 1, 18 becomes a 3, and now I have 3m on this side, because the over 1 goes away. Anything divided by 1 is just itself. So equals, and then over here, the 18 and the 18 cancel or divide, and so now I have 3m is equal to 15. And now I'm at a point where I have an equation without any fractions, so I can finish finish solving by dividing both sides by 3, and m equals 5. So I've got the same answer by doing two different ways. So this one here, I need to now solve this equation for x. I'm assuming, this one here has a and an x. So I'm gonna assume we're solving for x. The direction should have said to solve for x, right? So we're gonna put this in terms of x in terms of a. So I'm gonna use the method. I don't see a way to simplify each, so I'm gonna actually multiply each side by the denominator, the common denominator. And my common denominator in this case would be 28, right? Because it's 4 times 7. So I'm going to multiply by 28 over 1 over here and multiply by 28 over 1 over here. And that's going to allow me then to simplify my fraction. So that 28 and the 4 simplify 12 by 4, right? 7 goes into 7 once, 7 goes into 28 4 times. And the same thing here, the 4 and the 28 simplify. That becomes a 1, that becomes a 7. So I end up with 4x is equal to 7a, right? When I multiply, because I'm still multiplying, what I got here was that 4, and that 4 times the x is 4x. A times the 7 is 7a. So keep going. Now I've got to divide. I'm trying to get my x alone, right? So I'm going to divide both sides by 4. So when I look at this, I really have this 7a over 4. So I can leave my answer as 7a over 4, or I can divide those coefficients and write it 7/4 a. Okay? Either form of that would be the answer. Okay? All right, there we go.